There are multiple interlinked pathways in sickle cell disease, pathways of pathology that drive pathology. As you know, the primary lesion of sickle cell disease is the polymerization of the mutated hemoglobin, the sickle hemoglobin, that leads to hemolysis and leads to hyperadhesive, deformed red blood cells. And then this initiates a cascade of events that culminates in vascular dysfunction. And and so what links sickle hemoglobin polymerization to vascular dysfunction is obviously hemolysis, reactive oxygen species generation, ischemia reperfusion injury, an inflammatory state. All these factors are interlinked. And so the vascular dysfunction, though, is a final common pathway for a lot of what happens in sickle cell disease because it really it really leads to the chronic organ complications for which the disease is famous. We know, in fact, that although the polymerization of sickle hemoglobin is incessant because it happens every time the sickle red blood cells traverse through the venous circulation and they become deoxygenated. So this happens all the time, right? And it happens everywhere in the circulation. However, a lot of the complications of sickle cell disease are episodic. They are episodic and they are localized to certain territories, certain anatomical areas. And so this is because the vascular dysfunction is a more focal process. And it's characterized by endothelial dysfunction, nitric oxide depletion. It is characterized by overexpression of adhesion molecules that are very important in the pathogenesis of the disease. There are problems with von Willebrand factor as well, and a lot of these abnormalities were discovered in the sickle mouse models, and we now know they are relevant for human pathology because they've been the target of therapeutic interventions. For instance, crizanlizumab is the first FDA-approved therapy to target P-selectin, which is one of the main adhesion molecules implicated in vaso-occlusion. And there's been a number of other molecules under investigation, such as pan-selectin inhibitors, such as rivipansel, inclacumab, and with mixed successes, as we all know. And of course, that underlies the complexity of the disease, but there's no doubt that therapies aimed at vascular dysfunction are important. Of course, I should also mention there's been a lot of approaches to nitric oxide modulation, restoring nitric oxide in sickle cell disease, also with mixed successes. But this is still a very active area of investigation.